Imagine an airstrip built with a secret weapon, not a missile but pure engineering brilliance. How did a team of engineers overcome impossible odds to construct the groundbreaking PSP airstrip? Get ready to discover the innovative solutions and sheer ingenuity that transformed this project from a dream into a reality, pushing the boundaries of what we thought was possible in construction. 12 June 1944. Cardonville, Normandy, France. INS, Engineer Command, 9th Air Force. 816th Engineer Aviation Battalion, Cumders Brig. General James B. Newman, Jr. Lieutenant General Lewis H. Brereton. Dawn after D-Day. Bocage still smokes, the beachheads are thin, fighters need a place to land, refuel, rearm now. IX Engineer Command moves. A bulldozer coughs to life in a Norman pasture near Cardonville. Survey stakes go in, the clock starts. They do not bring concrete, they bring steel. Stacks of pierced panels roll off GMCs and DUKWs, long, narrow planks stamped with hundreds of round holes. Each plank is about 10 feet by 15 inches, corrugated for stiffness edges, punched with offset slots, so one panel bites the next. No bolts, no welding. You drop the tongue into the groove and stomp it home with a sledge, a runway by hand, one panel at a time. The template is simple. Grade the hedgerow field to a gentle crown so water runs off. Lay a compacted base with local soil, sand or crushed stone as available. Wherever the ground pumps underfoot, throw down geotextiles, primitive stand-in brush, Hessian, even brushwood fascines, then keep laying steel. Panels interlock in rows. Rows become mats. Mats become a fighter strip. The men doing it are the 816th Engineer Aviation Battalion under IX Engineer Command. They have practiced this choreography in England for months. Transit, unload, grade, mat mark, fuel, farm, bomb dump, taxi loop control, van flare path. Their doctrine is speed. Get tactical air power operating forward while the infantry still fights within earshot. Cardonville's ALG will be coded A3. Crews pace off 5000 feet for the main runway. Scrapers bite the sod. Graders follow. A tractor drags a light roller. Then the line of steel begins clatter, slide, hammer lock. The pattern is offset so joints never line up, spreading loads, avoiding ruts. Where hedgerow roots rise, axes go first, mattocks second, dozers last. If a panel will not seat it, gets swapped. Damaged planks move to shoulders and dispersals. The supply problem is savage and real. Each panel weighs dozens of pounds. Thousands are needed for a single runway. Yet convoys keep coming off Omaha and Utah, steering through traffic control points to CZs inland. Petroleum oil and lubricants for the fighter groups come with them in drums that will sit under camouflage nets beside hasty earthen berms. Bomb trolleys arrive. Pierced steel becomes streets to the hard stands. Engineer MP's post signs. A 3 takes form on a map as quickly as it grows in a cow pasture. By the second sunset, the line is long enough to measure in seconds of takeoff roll. A jeep bounces down the new surface, a test of flex and drag. The steel sings under its tires, a rippled hum that says the interlocks are tight. An officer kneels and runs a gloved hand along a joint. No lip to catch a tire. Good. Why pierced steel? And why now? Because mud is the enemy. Normandy's weather is a weapon that does not care who you are. A grass strip might hold one day and collapse the next. Concrete needs forms, cement, curing time weeks the battle will not grant. PSP, often called Marston mat, is instant stiffness. It spreads the wheel load, bridges, soft patches, sheds, water through the holes, and dries fast after rain. When a wheel chews a rut, you lift a few panels, dress the base, and lay them back. Maintenance is the same act as construction, modular, reversible, quick. The Luftwaffe notices. Recon photos from the days after 6 June show new scars in the fields, narrow, straight, unnatural. Intelligence estimates revise fighter range maps. A Thunderbolt or a Mustang that landed yesterday in England can land today at A3 refuel from drums, rearm from forward dumps, and be back over the front lines in minutes. German pilots will swear that American fighters appear too often, too far in too quickly. They are not wrong. Steel runways are collapsing the distance. Speed is not only laying panels, it is organization. ICE Engineer Command has pre-assigned tasks down to squad level. While one platoon lays the runway centerline, another runs taxiways to dispersals cut into hedgerow pockets. Camouflage crews drape nets. Signalmen erect a simple tower and string line for field telephones. A small control van, a caravan on wheels, parks near the approach end. A sandbagged revetment for a fire truck goes up in an hour. Everything essential, nothing ornate. Even the edges matter. The runway shoulders get extra rows of PSP to keep prop wash from eating the soil, to give a pilot a second chance if he strays. At the thresholds, engineers pin down the last panels with pickets so a bad bounce does not peel the mat. Whitewashed oil drums mark the perimeter. A windsock snaps on a pole made from a cut sapling. Night comes before the paperwork. It does not stop the work. A blackout lantern under a poncho gives just enough light for hands to find slots and tabs. Hammers keep time. Somewhere beyond the hedges artillery speaks. The mat goes down anyway. Within roughly 48 hours of the first stake fighters land. The steel shudders under the weight then holds. Brakes squeal. Ground crew run with chocks. Guns get reloaded. Fuel spills on steel, not mud, and runs off through the piercings. The sortie cycle tightens, land, turn, launch. The runway does its job without a word. This is not a miracle because it is sudden. It is a miracle because it is prepared. The miracle was built in depots, rehearsed on English grass, and delivered through a supply chain that reaches from Midwestern mills to Norman hedgerows. In the days that follow, more ALGs open across Normandy. A 1, a 2, a 4, each one, a steel answer to a tactical question. Cardonville is only the first note in a fast, relentless cadence. In the interwar years, the problem was known but unsolved: how to put a hard, all-weather runway on soft ground fast. Experiments tried timber brush matting crushed rock on geogrid precursors, even prefabricated concrete slabs. All worked slowly. The answer finally fielded to combat units was a stamped steel plank with 3 virtues: simplicity, strength, speed. Pierced steel planking, PSP, often nicknamed Marston Mat, looked humble. A 10-foot by 15-inch panel with corrugations for stiffness, hundreds of round holes to shed water and mud, offset slots along the edges so one panel locked into the next without bolts. The geometry did the work. Load from a fighter's main gear spread through the ribs across the interlocks into the base, not into the nearest mud pocket. Engineers learned to crown the strip slightly, a gentle, deliberate hump from centerline to shoulders so rain ran away. They laid the panels on a compacted base, graded native soil, if it would hold sand, or crushed stone if it would not. Where the subgrade pumped, they made fascines from brush or used Hessian layers as filters, then kept going. The panel pattern was staggered like brickwork to prevent long, straight joints that could open under braking. Where a joint sat proud, a sledge corrected it. Where a panel bent, it moved to a shoulder or a dispersal. The runway core stayed straight and true. The steel was not light, but it was manageable. 2 or 3 men could carry a plank. A detail could throw down yards in minutes once the base was ready. The tools were shovels, mattocks, sledges, pry bars and tractors to drag light rollers. No curing time, no formwork. If rain came, the holes bled the water off and the corrugations kept tires from hydroplaning on film. If a rut formed, lift a few panels, dress the base relay. The fix was the same act as the build. Doctrine, crystallized in England before D-Day. Engineer Aviation Battalions rehearsed the sequence until it became muscle memory, reconnaissance of fields with firm approaches, quick soil tests with a shovel and boot heel, alignment by compass and stake, so crosswinds stayed within limits, grading to crown, rolling, then matting fast from midpoint in both directions so an aircraft could land short before the full length was done. Taxiways and dispersals followed in parallel, not in sequence. What mattered was time to the first safe landing, not perfection. Cardonville proved the thesis in combat. Trucks and DUKWs ferried pallets of PSP inland from the beaches. Engineer MPs kept the flow moving through dusty crossroads where artillery units and medical convoys also fought for space. Fuel drums went under nets. Ammunition dumps took tree-lined corners away from blast risk. A control van and a windsock marked life. By the end of day 2, the steel had become a runway. By day 3, a base. Germany's reaction came in photographs and in pilot reports. Aerial reconnaissance mapped the new strip's thin metallic ribbons that appeared in hedgerow country almost overnight. Range rings on Luftwaffe plots moved the wrong way. Forward fighter presence expanded hours earlier than expected, then surged again after refuel and rearm cycles on French soil. Complaints filtered into German group diaries. Enemy fighters too numerous, too quick to return, too free to loiter. No new secret airplane explained it. Steel did. The Americans were not alone in using temporary surfacing. Other armies laid Sommerfeld tracking or other mats, but PSP hit the sweet spot of industrial capacity and field practicality. Mills could stamp thousands of panels. Liberty ships could stack them dense. Beach parties could unload them rough. Engineer battalions could lay them with hand tools in any farm field wide and straight enough to matter. Every step matched the scale and tempo of the theatre. The details kept pilots alive. Threshold panels were pinned so a bad bounce did not peel the mat. Shoulders were double-rowed where prop wash and crosswinds chewed the soil. Dispersals were cut into hedges and matted so turning wheels did not dig traps. Taxiway curves were widened with extra panels, so a fully loaded fighter did not drop a main wheel off the edge when a pilot looked back at a wingman. White oil drums marked perimeters. Blackout lanterns marked flares. Everything had a reason, and the reason was speed with safety. There was friction always. A wet subgrade pumped. A dozer broke a tooth on buried stone. A panel batch arrived slightly out of tolerance and needed persuasion with a sledge, but the system absorbed friction. Replace a plank, shift a joint, add a brush layer, send a roller one more pass. The runway flexed and lived more like a bridge than a road, and that was the point: distribute, drain, endure. By week's end, a 3 was part of a pattern. Other advanced landing grounds opened. A 1, a 2, a 4, each punched into pastures and edges of orchards by teams who knew the dance. Fighters used them hard. The steel sang under tires, and prop wash a bright metallic hum that carried down the hedgerows. To the infantry, it meant cover overhead. To the engineers, it meant the interlocks were tight and the base was holding. This was a breakthrough born of patience more than inspiration. The AHA lived in the clean edges of stamped slots and the discipline of laying them straight. Manufacture in depth, training in depth, supply in depth. Then, when the front moved, lift the panels, truck them forward and do it again. Speed was not magic. Speed was a method. The schedule is not a line on paper. It is a roar. Surf at the beaches. Engines in the hedgerows. Artillery up ahead. Every minute without a runway is a sortie lost and someone at the front pays for it. Convoys feed the build. Liberty ships offload pallets of PSP into LCTs and DUKWs. Drivers grind CCKW 2 half-ton trucks inland through MPs at choke points. Whiteboards flip no halts, reroute red. Dozers Caterpillar D7S with cable blades nose into sod and roots. Scrapers take shallow bites. Graders finish. A light roller hums. Then the steel starts panel after panel, shoulder to shoulder, hammer to slot, slot to tab. The choreography never stops. Weight is the tax. A single fighter strip eats hundreds of tons of planking. Each plank rides twice, ship to shore, shore to dump, dump to line. Hands carry the last yards, gloves tear, palms blister. A sledge rings out wrong, fit again, now it seats. A corporal checks the crown with a level. A lieutenant squints down the centre line at a stake in the distance. Keep it straight. Keep it crowned. Drain is life. Weather presses. Normandy shifts from dust to rain in an hour. Mud pumps under boots. Engineers answer with brush layers, fascins and hessian to filter fines. When the base moves, they lift 3 panels, dress the subgrade, lay them back. When the rain quits, holes shine with standing water, then bleed dry. The mat survives because it breathes. The enemy presses too. Luftwaffe reconnaissance circles high. A staff car brings a warning from the air commander, expect harassment. Camouflage crews throw nets over stacks of planking. White oil drums become muddy within minutes. A sandbagged revetment grows for the fire truck. The strip is not a secret, it is a race. Speed is organization more than muscle. IX Engineer Command runs parallel lines of effort, runway matting from midpoint both ways. Taxi loops cut into hedgerow pockets, dispersals tucked under trees. Fuel farm graded and diked before the first drum rolls in. Bomb dump set at a safe corner, matted paths for trolleys. Signals raise the windsock and lash a field phone line to a sapling tower. The control van parks where the approach can see it. A box on wheels, a voice on the radio, a hand with a flare. Mistakes happen, they are contained. A batch of panels arrives out of tolerance, edges shy by a quarter inch. The sledge persuades. A dozer bites a buried stone and jumps a tooth. The other dozer takes the pass while the mechanic's chest wrench and a bar fix the sprocket. A joint sits proud and chews a tire on a test jeep. The chief of section pulls the run relays 3 lengths, checks with a gloved palm smooth now. The system bends and returns to shape. Pilots test before anyone declares victory. A liaison plane comes first light forgiving, then a fighter heavy honest. The approach is flat over hedges, wheels chirp on steel brakes, bite tail settles. The runway shudders. It holds. A crewman jogs in with chocks, another flips open a fuel drum and feeds a hand pump. A third checks gun bays, links click, turn times compress from hours to minutes. A 3 is alive. Pressure is continental, not local. Units inland wait for their turn. A 1, a 2, a 4 each pasture, each edge of an orchard gets its stake line and its steel. Schedules collide, artillery needs the road, ambulances need it more. Engineer MPs move convoys like blood through arteries. When a knot forms a captain at the TCP, flips the board reroute red, and the flow shifts around the blockage like water around a rock. And then there is the Pacific, a different war, the same math. Coral atolls. Jungle and monsoon. Naval construction battalions. Seabees throw down Marston mat over crushed coral and coconut log fills. On one island, a bomber strip appears between palms, where yesterday was swamp. On another, fighters claw mud from their tires, and then stop clawing the steel carries them. The material is the same. The method is the same. Grade, crown, mat, disperse. Speed is the constant. Logistics never sleeps. PSP leaves the factory in stacks. It rides trains to ports, ships to beaches, trucks to farm gates. A panel buckles under a brake skid. It does not become scrap. It becomes a shoulder. Nothing is wasted. When the front moves, crews lift the mat in sections, stack it, lash it, and truck it forward. The runway is a machine that disassembles and reassembles faster than concrete ever could. Safety rides shotgun with speed. Thresholds get pickets so a bad bounce does not unzip the mat. Taxi curves get extra rows so a fully fueled fighter does not drop a wheel. Flare pots and blackout lanterns mark the edges at night, small lights shielded just enough to land by not enough to draw fire. Fire extinguishers sit at intervals. A ditch carries runoff away from the fuel farm. The checklists look plain. They save lives. There is pride, quiet, unadvertised. A private slides a palm along a joint and smiles when it is flush. A sergeant counts swing tempo by the sledge strokes and grins when his squad picks it up. An officer writes a single word in the log, operational, and underlines it once. The first mission out is not theirs to fly, but the runway is theirs to give. Germany feels the pressure as data. Reconnaissance photos from one day to the next, empty pasture, then a grey strip like a blade. Range plots get rewritten. Reports complain enemy fighters return too fast too often. There is no marvel to point at, no secret wing, no new engine, just steel and men who know how to use it under fire and rain. By the end of the week, the cadence is set. Build, fly, lift, move, build again. The map fills with codes and short names. A 3 Cardonville, a 6 Buseville, a 10 Carenton each. A promise that air power will not lag the infantry by days, only by hours. Pressure becomes tempo. Tempo becomes advantage. War ends. The steel does not. Piles of pierced planking stand at depots, airstrips, quarries, farm edges. It looks like scrap. It is a toolkit. Engineers lift miles of mat from European fields and Pacific atolls. Panels go to ports, then to yards. Municipal crews buy lots at auction. Farmers buy by the stack. The panels become hard stands for tractors loading spurs by elevators, winter approaches to barns. County road crews bolt short bridges with steel beams under PSP decks, a fast bypass while a culvert is rebuilt. Harbour men lay it on pier tops for forklifts. Oil crews throw it across muskeg and salt flats. Anywhere that soft ground defeats tires, a strip of old war steel makes a way. Air power keeps the idea alive. Korea comes. Many World War II stocks return to service. Steel on graded earth. Fighters and transports hammer down and back up. Lessons repeat, crown the strip, stagger the joints, pin the thresholds. Then aluminum arrives. AM2 mat appears in the 1,950 seconds and 1,960 seconds, lighter tongue and groove faster, to lay kinder to tires. Vietnam takes the baton. Expeditionary airfields spread over red clay and sand. The principle is unchanged modular interlocking surface over a shaped and drained base, only the metal and the locks evolve. Civil work tracks the same curve. Temporary construction sites need stable pads for cranes. Crews lay, mats build, lift mats move on. Utility companies use panels to cross wetlands for line repair, without tearing a rut that will drain a bog for a generation. Disaster relief teams keep sets of roadway mats on pallets. When floodwater drops, they lay lanes for ambulances to reach neighborhoods where asphalt failed. The panels are not magic. They are simply faster than pouring a road when speed is the difference between access and isolation. Design language migrates. Interlocking plates, load-sharing ribs, joints that resist peel. PSP wrote those phrases in steel and time. Modern versions speak aluminum composite and high-density polymer. Trackway systems in aluminum unroll like a ribbon and carry 60-ton loads across dunes. Molded polymer grates clip together to make wheelchair access over sand. Geocell grids, honeycombs that confine, aggregate, borrow the same truth, spread load, stop rutting, shed water. The vocabulary is different. The grammar is the same. The military codifies the method. Expeditionary airfield handbooks define survey, soil test, crown base, course matting, and repair. Airfield damage repair kits assume that a runway can be cratered at dawn, and operating by dusk plate, a hole fill the scarf, mat the patch, paint the lines. Tactical bridging kits use deck panels with pinned joints that echo PSP logic. Short spans, fast assembly, predictable stiffness. It is all one family of ideas. There is a civic echo too. Post-war housing booms need speed. Builders learn panelization, walls and floors built off-site and set by crane. Containerization rewrites logistics ISO boxes with corner castings that lock, stack and spread load through a steel frame. Highways adopt modular median barriers with tongue and groove ends and pinned joints. Stadiums use demountable turf protection panels so a field can carry a concert tonight and football on Sunday. None of these are runways. All carry the same chromosome repeatable units whose joints are the invention. Sometimes PSP itself shows back up. A rural county reuses stock for a festival parking field that turns to soup after rain. A forest service grades a fire base in spring and lays old panels so heavy tankers can load retardant. Archaeologists protect a dig with mats so wheels do not crush traces. A museum displays 10 feet of pierced steel and a black and white photo of men with sledges, a short chapter from a long book. The environmental arc bends too. Steel is energy intensive, so the field shifts to aluminum for weight and corrosion resistance, to polymers for handling and recycling, to geosynthetics for base separation and filtration. The aim is lighter, faster, less fuel, less soil damage, more reuse. The ghost of PSP nods. The goal was always to put strength only where needed, in ribs, in interlocks, in the places where tires bite and brakes pull. The idea scales up and down. At the small end, campers lay compact mats to keep a van from sinking at a trailhead. At the large end, joint logistics teams build a temporary port from causeway sections and matting, so ships without piers can unload trucks to the beach. Temporary heliports sprout in cities after earthquakes, aluminum panels over crushed stone on a vacant lot. A tilt rotor lands where yesterday there was only mud. What remains after the steel is the habit. Look at ground as structure, not scenery. Test it, shape it, drain it. Then place a minimal surface that carries the load and can be removed when the job is done. That sequence is humble, almost dull. It is also one of the quiet reasons modern societies can move fast without leaving scars everywhere they go. And legacy is human, not only metal. Veterans of Engineer Aviation Battalions and Naval Construction Battalions trained a generation of civil engineers, road foremen, equipment operators, logistics officers. They brought field sense into peacetime codes and job site rituals. Measure the crown, check the joint with your palm, pin the threshold, protect the edge. If a fix takes longer than a relayed panel, you are fixing it wrong. Those lines echo on job sites where no one recalls Cardonville by name, but everyone knows how to keep a truck from bogging at the mouth of a job. A memory endures in sound. Some pilots who flew from steel strips remember the metallic hum as tires sang over corrugations. Today, a crane crawls over aluminum trackway that rings under its pads. The tone is different. The meaning is not. Someone prepared the ground so work could begin. Someone will lift the surface when the work is done. The place will breathe again. The war that pushed pierced steel into pastures and jungles is gone. The method remains a simple, sturdy grammar for turning soft ground into a tool, quickly, safely, and without drama. That is the enduring miracle. They did not sign their work. They signed for it on line cards, on rail receipts, on stacks of panels pulled from a depot before dawn. Names are in unit rosters and morning reports, not on monuments. Yet, the cadence of their labour-grade crown mat disperse, stitched air power to the ground where it was needed most. Watch a squad on the line. A private holds a plank to the edge angle right now. A corporal checks the crown with a level and a boot heel. A sergeant listens to the joint under a Jeep tyre and hears the truth, tight or not. A lieutenant walks the centre line with a stake and string and fights the drift that wind, haste and hedgerow roots whisper into every job. No speeches, no music, just the sound of sledges, the hum of rollers, and the metallic ring of success when a panel seats clean. IX Engineer Command wrote doctrine, and it mattered. Naval construction battalions carried the same grammar across coral and jungle. But doctrine without hands is paper. Hands turned stamped slots into a runway before the second sunset. Hands lifted the mat when the front moved and set it again by the third sunrise. Hands learned the tricks that never make manuals, how to keep a joint from peeling under a bad bounce, how to read soil with a shove of a shovel, how to hear a soft spot before a tire finds it. There was courage, not the poster kind. Work under harassing fire is still work. A man keeps swinging a sledge when artillery thumps a field over. A dozer driver leans into a cut while a reconnaissance plane circles high. A lantern under a poncho makes a small cave of light where fingers find slots and pins in the dark. No duel, no lone hero theatre, just persistence under pressure, the quiet bravery that keeps machines of war and mercy fed. Their pride was precise. A palm laid flat across a joint, a glance at a curve where a taxiway widens so a loaded fighter will not drop a wheel, a nod when a liaison plane chirps tires on steel and rolls straight. Pride that a runway sings the clean metallic note that means interlocks are tight and the base is holding. Pride that a control van can say one word clear and mean it. After the war, the habit travelled with them. Many became county foremen, civil engineers, surveyors, heavy equipment trainers. They brought field sense to peacetime. Check the crown. Drain before you pave. Spread load. Fix by replacing modules, not by patching in place. Protect the edge first. If a repair takes longer than a relayed panel, you are repairing it wrong. Those lines echo still on job sites where no one says Cardonville out loud, but everyone builds like they were there. Innovation does not always arrive as a new material. Sometimes it arrives as a better joint, a faster sequence, a lighter lift per man. The spirit of PSP lives wherever small parts connect fast and carry loads safely in aluminum trackway that unrolls behind a truck, in composite mats that two workers snap together without tools, in geocell grids that turn loose fill into a firm base without pouring a yard of concrete. The metal can change, the method remains. The next chapter looks forward without romance. Disaster teams keep mat sets on pallets, flood recedes, lanes are laid, ambulances pass. Fire bases appear on forest flats with panels under tanker trucks. Humanitarian convoys bridge mud with temporary roadways that lift when the season turns. Expeditionary airfields grow from gravel and aluminum, where only scrub stood the day before. None of it asks for applause. It asks for readiness, rehearsal, and supply, the three quiet virtues that made steel runways appear in a French pasture when the world needed them. Look higher and the logic still holds. Autonomous graders already read a crown from GPS. Drones map soft ground by inference from micromotion. In video pick the line of best bearing surface, stake it fast move. Robots can carry panels 2 at a time and place them to a millimeter with vision-guided arms. A small team can do a week's work in a day because the sequence is tight and the joints are forgiving. If tomorrow's airfield is on sand, polymer and aluminum will serve. If it is on dust, beyond weather and tide, other materials will come sintered, regolith plates, interlocks cut by laser, but the grammar will be familiar: shape drain, mat mark fly. Credit remains human. The habit of looking at ground as structure, not scenery. The instinct to test with a boot, not a guess. The discipline to lay the first panels dead straight when speed tempts shortcuts that always cost more later. The patience to lift a bad run and relay it clean. That is not romance. That is craft. The story ends where it began, with a need and a clock. The beachhead is a memory now. The pasture at Cardonville is quiet. Somewhere else a crew sets stakes in soil that will try to swallow their work if they let it. They will not. They will crown the line, lay the mat, pin the threshold, mark the edge, and hand the surface to pilots, drivers, medics, or neighbors who need it. The world will move because people prepared a place for motion, not a miracle because it is sudden. A miracle because it is prepared by engineers and laborers who work fast, think ahead, and leave only the hint of a metallic hum in the air when the job is done.